Universitas Trisakti merupakan salah satu universitas swasta yang terkenal dan terfavorit di Indonesia yang terletak di Grogol, Jakarta Barat. Saat ini Universitas Trisakti memiliki 45 program studi yang tersebar dalam 9 fakultas, 6 program diploma, 23 program sarjana, 12 program magister, 2 program doktor, 1 program spesialis, dan 1 program profesi yang tersebar di berbagai lokasi. Di dalam kampus A ini terdapat 7 fakultas, yakni Fakultas Hukum, Fakultas Ekonomi, Fakultas Teknik Sipil dan Perencanaan, Fakultas Teknologi Kebumian dan Energi, Fakultas Teknologi Industri, Fakultas Arsitektur Lanskap dan Teknologi Lingkungan, dan Fakultas Seni Rupa dan Desain. Selain kampus A, Universitas Trisakti memiliki kampus B di Jalan Kiai Tapa, Grogol, Jakarta Barat. Di kawasan kampus B, Universitas Trisakti terdapat Fakultas Kedokteran dan Fakultas Kedokteran Gigi. Semua fakultas telah terakreditasi dan didukung oleh berbagai fasilitas yang lengkap dan komplit, sehingga menunjang proses perkuliahan yang komprehensif dan paripurna. Universitas Trisakti sangat fokus dan konsisten dalam bidang pendidikan. Didukung dosen yang memiliki kompetensi di bidangnya, tergambar dari dukungan puluhan guru besar dan doktor, serta tenaga pengajar yang hampir seluruhnya memiliki jenjang akademik magister atau S2 dan doktor atau S3, dan lebih dari 50% dosen memiliki sertifikasi keahlian. 100.000 lebih alumni dari berbagai fakultas di Universitas Trisakti tersebar di berbagai bidang profesi, baik pada institusi pemerintah, swasta, serta dunia usaha, baik di Indonesia maupun di mancanegara. Keberadaan alumni juga membuka akses dan kesempatan bagi mahasiswa dan alumni baru meraih masa depan gemilang.
Jadi teknik mesin itu kita diajarin gimana caranya ngerancang suatu part mesin. Salah satunya itu mobil, motor, bahkan pesawat, Rak.
Iya.
Betul banget. Dan kita juga bisa ngitung efisiensi mesin pesawat itu. Selain itu, kita juga belajar tentang materialnya kayak logam, besi, baja, gimana caranya itu materialnya itu cocok untuk dijadikan suatu blok mesin. Selain itu, kita juga belajar tentang entrepreneur, manajemen teknik, dan etika engineering. Jadi kalian nggak usah takut untuk masuk teknik mesin, karena kita nggak hanya belajar tentang teknik, kita juga diajarin tentang pengetahuan ilmu bisnis gitu juga.
Dan juga teknik mesin Universitas Trisakti pernah melakukan rekor muri dan rekor dunia sampai 6 kali. Sangat ambisius itu mahasiswa teknik mesin Universitas Trisakti. Dan juga prestasi-prestasi mahasiswa Universitas Trisakti itu sangat didukung. Contohnya seperti saya pernah menjadi Abang None Jakarta Kepulauan Seribu 2019. Dan juga teman saya Ica yang di sebelah saya nih pernah menjadi juara karate tingkat dunia.
Wow.
Jadi apa yang kalian tunggu?
Untuk program unggulan yang ada di sini, kita punya studi trip. Nah, studi trip itu apa sih? Studi trip itu kita pergi ke suatu perusahaan atau universitas, di mana kita bisa melihat alat dan perkembangan industri di sana. Untuk tahun ini, kita udah pergi ke NTU Singapura loh. Seru banget ya, Bi?
Untuk di Elektro Trisakti, ada 5 konsentrasi jurusan loh. Ada arus kuat, ada telekomunikasi, ada sistem kendali, ada elektronika, dan ada sistem komputer. Dilihat dari 5 konsentrasi tersebut, nampaknya elektro untuk di masa yang akan mendatang akan sangat luas prospek ke depannya. Program unggulan dari Elektro Trisakti sendiri ada beberapa hal, salah satu yang paling utamanya yaitu radio wave. Radio wave itu adalah lomba drone tingkat nasional yang diadakan oleh Teknik Elektro Universitas Trisakti. Lomba drone ini sudah dilakukan sebanyak 2 kali. Tahun ini kita sudah lakukan pada bulan Maret dan kemudian pada tahun depan untuk seri yang ketiga akan dilaksanakan rencananya pada bulan Februari. Untuk prospek yang kedepannya, teknik elektro sangat luas. Kita suka merakit drone dan bermain dengan robot. Tentunya di masa yang akan datang, menyamaratakan distribusi sinyal di seluruh Indonesia. Atau dengan kata lain, membantu beberapa wilayah di Indonesia untuk mendapatkan kualitas sinyal yang jauh lebih baik. Jadi nggak susah sinyal lagi deh.
Dan untuk prospek kerja ke depannya, kita bisa menjadi konsultan di bidang elektrikal dan melakukan inovasi di bidang kelistrikan yang dapat membantu manusia di masa yang akan datang.
Jurusan teknik industri itu ngebahas banyak banget kayak bidang keilmuan, mulai dari manufacturing sampai manajemennya. Tapi kalau di teknik industri Trisakti itu sendiri lebih fokus ke bidang manufacturingnya. Ada PIM 1, PIM 2, PIM 3, dan PIM 4. Dari situ, kita merancang mini pabrik kita sendiri dan memasarkan produk yang sudah kita rancang di PIM 1 sampai PIM 4 tadi di IBF yang akan dilaksanakan pada semester 7. Jadi nanti setelah lulus kita lebih kebayang tuh gimana nanti kita kalau di pekerjaan di real life-nya.
Jadi kan teknik industri ini kita juga mencakup banyak bidang, dari mulai kita diajarin gimana cara kita ngatur keuangan, gimana cara kita manage organisasi, sampai kita desain produk dan gimana cara kita memproduksi suatu produk itu sendiri. Nah, itu juga alasan kenapa aku milih jurusan teknik industri, karena emang teknik kan nggak terlalu keteknikan, dan kita juga mencakup semua bidang. Dari mulai di semester-semester awal tuh kalian ngedesain stasiun kerja gimana, nanti sekalian udah lebih naik lagi tingkatannya, kalian belajar gimana cara production planningnya, sampai di akhir kalian buat template perusahaan itu, dan juga di semester akhir kalian bakal bikin suatu produk itu sendiri dari awal. Dan cara-caranya gimana kita bisa menjadi wirausaha.
Yang sudah kita pelajari di Teknik Informatika dan Sistem Informasi adalah keamanan jaringan, pengelolaan database, pemrograman perangkat lunak dan framework, manajemen data, dan pembuatan animasi dan game. Dari pengetahuan yang sudah kita pelajari di kampus, nanti akan ada yang namanya penerapan kuliah kerja profesi, di mana kita dapat menerapkan ilmu-ilmu pada di kampus untuk diterapkan di dunia kerja.
Tentunya alasan untuk memilih teknik informatika dan sistem informasi ini adalah karena industri kini sudah memasuki industri 4.0. Maka dunia IT itu sudah menjadi bagian kebutuhan primer dari adanya industri masa kini. Profesi yang bisa kalian geluti itu adalah antara lain programmer di bidang perangkat lunak, cloud computing, security, cyber security untuk keamanan jaringan dan informasi. Kemudian ada juga manajemen database ataupun data. Kemudian ada pemrograman web dan juga pemrograman game. Tentunya semuanya itu sangat dibutuhkan di perusahaan masa kini dan prospek kalian tentunya sangat bagus ya.
Mengikuti perkembangan teknologi yang ada saat ini, di mana kita harus mengikuti industri 4.0, maka di Fakultas Teknologi Industri kami telah mempunyai Smart Classroom, sehingga semua proses belajar mengajar dari 5 program studi yang ada di Fakultas Teknologi Industri telah mengikuti perkembangan teknologi saat ini. Perlu kami sampaikan, di Fakultas Teknologi Industri kami mempunyai 5 program studi sarjana, yaitu teknik mesin, teknik Informatika dan Sistem Informasi yang mempunyai akreditasi B, dan teknik mesin sekarang dalam proses akreditasi internasional IABI, yaitu Indonesian Accreditation Board of Engineering Education. Sedangkan untuk teknik elektro dan teknik industri sudah mempunyai akreditasi A dari BAN PT dan mempunyai akreditasi internasional dari IABI.
Honorable Head of Industrial Engineering Department, Faculty of Industrial Technology, Trisakti University, Dr. Rina Fitriana, STMM IPM, dear all industrial engineering lecturers and especially all participants of this Studium Generale. Today, Wednesday, 20th October 2021. Ladies and gentlemen, I am Debbie Kemalasari, the moderator of today's Studium Generale. I am very happy to see you here and welcome all of you to this session. Welcome to all participants from several universities and other institutions. Total of registered participants today reached 390 participants. Today, Studium Generale is about production system, operation, and supply chain management. Ladies and gentlemen, our speakers today are Professor Beni Cahyono from Coventry University, United Kingdom, and Professor Dadan Umar Daihani from Trisakti University. Hello, Professor Beni and Professor Dadan. Welcome. I am a big fan of you both professors.
Good afternoon. Good afternoon, Professor Cahyono.
Good afternoon, Prof.
Yeah, thank you.
Okay. Before the presentation start, let me tell you the rundown of this Studium Generale. First, we will singing of the national anthem Indonesia Raya, then greeting speech from Head of Industrial Engineering Department, and then we will enter the main sessions. The speakers will deliver the presentation about 1 hour, and after that, we will open the Q&A session. This Studium Generale will end with the certificate award for our speakers today and group photo session. Okay, ladies and gentlemen, singing of National Anthem Indonesia Raya.
Indonesia tanah airku, tanah tumpah darahku. Di sanalah aku berdiri, jadi pandu hidupku. Indonesia kebangsaanku, bangsa dan
we will continue with the greeting speech from Head of Industrial Engineering for Dr. Rina Fitriana, STMM IPM. The time is yours.
Okay, thank you, Mrs. Debbie. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Welcome, Prof. Beni Cahyono, Professor of Sustainability and Supply Chain Management from Coventry University, United Kingdom, and Professor Dadan Umar Daihani, Professor from Industrial Engineering, Trisakti University, as a speaker in this Studium Generale. This event is part of the program Kompetisi Kampus Merdeka, competition program Freedom Campus Grant. Today, Department of Industrial Engineering, Universitas Trisakti proudly presents Studium Generale with the theme Studium Generale of Production System, Operation and Supply Chain Management. The speaker in this Studium Generale is Prof. Beni Cahyono. The topic is the Buying of circular economy business model in operation and supply chain management, and Prof. Dadan Umar Daihani, Professor of Industrial Engineering Department, with the topic challenge of production system toward autonomous age. Department of Industrial Engineering, FTI, Universitas Trisakti, has been accredited Unggul Ban PT and accredited International IABI General. Industrial Engineering Department have been produced more than 6,500 graduates who have been successful in manufacturing and service industry. Thank you to all community who have worked so well so this event can be carried out smoothly. Thank you for all participants of lecturer and student for all university who have been attended. Hopefully today's Studium Generale will go well. I will open the Studium Generale by reading Bismillahirrahmanirrahim. Thank you very much.
Dear all participants, for our first topic, please welcome Professor Beni Cahyono. Hello, Professor Beni.
Good morning UK time. Good evening. How are you?
Prof, nice to meet you again. Okay, Professor Beni, before your presentation begin, let me introduce you to all participants.
Thank you.
Professor Beni Cahyono is Doctor of Philosophy in Manufacturing System from Cranfield University, 2003. Master of Science in Engineering and Management of Manufacturing System from Cranfield University, graduated in 1999. Bachelor of Engineering or Sarjana Teknik in Electrical Engineering from Surabaya College of Engineering, Indonesia, graduated in 1994. Beni Cahyono is Professor of Sustainability and Supply Chain Management and also a co-leader of the Sustainable Production and Consumption Cluster at the Center for Business in Society, Coventry University, United Kingdom. His overarching research area includes sustainable operation and supply chain management, in particular, the exploration of circular economic principles in manufacturing and supply chains. He has a vested interest in ensuring the achievement of the triple sustainability objectives, doing good for people, planet, and profit. His research track record has been demonstrated by winning the successfully delivering several research grants from EPSRC, ESRC, Innovate UK, European Union, overseas funding agencies, and directly from the UK industry. He was one of the principal investigators and a member of consortium consisting of 7 universities in Europe recently being awarded the Horizon 2020 MSTA Innovative Training Network, aiming to formulate the service-oriented business for the European circular economy. His most recent research grant was funded by the Academy of Medical Science Global Challenge Research Fund, GCRF, in the area of circular food supply chain. Currently, he is leading 3 research projects. One is funded by ESRC in the area of social innovation of bioplastics, and the others are funded by EIT raw materials to investigate the recovery of metals in facet industry, and the EU Erasmus to equip engineering students with entrepreneurial skills. He is one of the founding members of the newly established UK-Indonesia Consortium for Interdisciplinary Science, with an aim of harnessing the research and knowledge transfer activities between the 2 countries in the topical areas of resilience and climate change. Professor Cahyono is actively involved in nurturing Indonesian postgraduate students, young researchers, and academic colleagues in the UK and Indonesia. In total, he has over 30 university partners in Indonesia. Okay, that's a short biography of Professor Benny. Maybe I need 3 days to read all about Professor Benny activity. Okay, Professor Benny, the time is yours.
Thank you, Bu Debbie, and very good morning UK time to colleagues in Indonesia, particularly in the Trisakti University. As mentioned before, my name is Benny Cahyono. I am a professor of sustainability and supply chain management at Coventry University. It's my great honor for me to be invited to deliver this lecture at the Industrial Engineering Department at University of Trisakti. And in the next hour or so, I am going to share some of the insights from the very topic of circular economy business model and how this might change the operations and supply chain of the future. So I'm going to start my lecture with this slide. Hopefully you can see this slide. Oh, hang on, I haven't shared it to you. 1 second. Share screen. There you go. So hopefully you see the pictures I'm talking about now. So I have 4 pictures here to start my presentation with. So I'm pretty sure that majority of you, or all of you, I'm sure, that more than 260 people attending this webinar this morning will know this picture. This picture is all about supply chain, about production, warehousing, and also anything to do with supply chain. But if I show you this picture, you might be thinking, what are these, what do these pictures share in common? What are the commonalities amongst this picture? How would I look into aircraft engine and similarity with food waste, and how additive manufacturing or 3D printing parts to do with polluted river? So you might be thinking about this, but I'm going to, I just want to ask you to hold on for the moment for the answer, as we are going to look into this in a bit more detail in a few moments. So supply chain. What is a supply chain? For me, the answer lies on the fact that it is what it says on the tin. It is a chain of supply and demand, chain between supplier and customer. So in this picture, you'll see this gentleman is buying dates, lots of dates, and the seller or the supplier supplies or fulfills the demand. When the supplier fulfills the demand of the customer, we will have this chain of fulfillment. Yeah? And in everyday life, for example, someone, customer, let's say Joe, comes to a local supermarket, convenience shop every day and buys a bottle of Coke. And if you think that this is all about fulfilling the supply and demand, the questions are about what is the demand and how many is the demand and what price are we going to pay? So, as I said before, this customer, Joe, comes to this local convenience store every day to buy a bottle of Coke. And for that reason, the supermarket, maybe Alfamart or Indomart, will then have their stock of, let's say, 30 bottles of Coke every month to fulfill the demand of Joe. And if Joe increases the demand to 3 bottles of Coke every day, then obviously it's quite easy calculation by these retailers to provide 90 bottles of Coke. And similarly, if Joe comes with his friend Jack to buy 2 boxes of orange juice, then Alfamart or Indomart will be easily provide or prepare for the inventories of 90 bottles of Coke and 60 bottles of orange juice. A very simple math. So here you can see the relationship between Joe and the shop forms the smallest constituent of a supply chain. So it is interesting that the term supply chain does refer to supply chain, not a demand chain. Though I must say, if you look into the literature, the term demand chain exists, but probably with a slightly different focus. So with the focus of supplying the orange juice or Coke to Joe and Jack, the retailer then buys or needs to buy from the larger retailer or distributors. And similarly, the distributors would need to source from other larger distributors and perhaps directly to the company that makes the beverage. So the links between Joe and the shop and the retailer, the shop and the distributor and the manufacturer actually forms a supply chain that can be defined as a set of 3 or more companies directly linked by one or more of the upstream and the downstream. All in all, the objective or the aim of this relationship or linking is to match the supply and demand. So if you think that if Joe comes every day to buy a bottle of Coke, and then the idea of the supermarket is fulfilling the demand of Joe, every day or every month, it sounds simple, isn't it? But the reality is that until now, the supply chain remains complex. And so my next question to you would be, what makes supply chains complex? There must be something that causes the supply chain to turn into a complex system rather than a simple mathematical calculation of 2 times 30, 3 times 30, as you see in the previous slide. Well, there are many reasons for this, but at least I would like to show you the first one, which is this one. If you look at supply chain, in reality, it is not that simple because one retailer can serve many customers and one distributors can serve many retailers. And of course, the distributors can be served by many factories. And the supply chain is not going to be a supply chain anymore, but rather a supply network. And if you imagine the change from a linear supply chain into a supply network, that makes the whole thing becomes more complex. And the complexity increases when there is the so-called demand amplification. And this demand amplification occurs because of the inability of the stakeholders in the supply chain to view the supply chain in a transparent manner. So, for example, a particular retailer predicts that the customers want a certain number of Coke or orange juice, in this case Joe, with the predicted demand that Joe comes every day to buy a bottle of Coke, 1 bottle of Coke. It's very easy. But if Joe sometimes comes, sometimes he doesn't come, sometimes he buys 1, sometimes he buys 3, that makes a confusion to the retailer, to the shop. To be safe, the retailers normally prepare or increases the level of inventory just in case the customers want to buy more. And that change of demand, the change of demand will be read by the upstream of the supply chain as an increase of demand. And therefore, the upstream supply chain will also increases the level of inventory. If everyone in the supply chain increases the level of inventory, ultimately, at the end of the line, for example, in this case, in the factories, then the factory thinks that the demand is huge. But in fact, the demand is not that big. It's just because it's amplified. This phenomenon of demand amplification, or also known as bullwhip effect, really give griefs to the players, the stakeholders of the supply chain, because everybody has to deal with the level of inventory. And finally, this is probably simplest in terms of understanding it, because what makes supply chain complex is the customers themselves. And when you look at the demand from the customers, certainly the customers wants to have a high quality product. It means that if they buy a bottle of Coke, then they would expect that the Coke will taste like a Coke, not Sprite or Fanta. And afterwards, if a customer wanted to buy the Coke, they expect that the Coke will be available immediately, and of course at a reasonable price. So this three things is very, very common and typical in industrial engineering and in business. Everybody wants quality, delivery, and cost, yeah, or low cost. Let's take a look at how quality can be affected. Yeah. The product quality certainly depends on the quality of raw materials. Yeah. So if you want to produce high quality product, then the basic principle is that you need to have good quality of raw materials. And afterwards, you need to have a good quality of production processes. And that's the reason why you are all learning about total quality control, quality management, statistical process control charts and everything, to ensure that production processes are all in control and ultimately guarantee or ensure the quality of the products. However, suppose that you have produced this product. What next? The product needs to leave the factory, yeah, needs to be distributed, needs to be delivered to the customers. So the quality of that product will then dependent on how we're handling that product. So if the product is fragile, then we have to be careful. And similarly, when we're transporting the product, when we store the product, and the product requires a certain temperature, vaccine, for example, or meat or fruit and vegetables, then we are required, or we need to have good quality of the process to store the product. So all in all, you might realize now that it's not just about the four walls of factories, but also outside the factories. And that's similarly with the availability and time. So what determines the time of this product to reach the customers? Obviously, the first thing is that the time to make the product. And that's the reason why you learn lean manufacturing, just-in-time production, Toyota production systems, everything that aims to reduce the production time. Yeah, because if you could reduce the production time, then certainly you would reduce the lead time or to improve the availability of the product to the customers. However, again, similarly, once the product's leaving the factories, then it's depending on how quick we can deliver the product to the customers through our distribution centers, through our warehouses, as well as delivered with our vehicles. And finally, cost. As I said to you before, good quality raw materials will come with cost, obviously, but we do need to ensure that the cost of production can be reduced. And this is also linked with the lean manufacturing. All in all, what we want to do is to reduce waste, which means that we're going to reduce the cost too. However, when the products leave the factories, then we need to take into account the cost for transportation, cost of warehouse, cost of labor or staff to handle the product, cost of storing, cost of inventory, and of course the insurance of that product. So you see, these cost, quality, and delivery, although it's pretty simple in terms of, everybody knows this, but when it comes into supply chain, it can make or it can influence the whole supply chain. It can make it more complex. The last thing is the so-called compounding cost. And this means that this is unintended consequences of something. Say, for example, if you promise to deliver certain amount of inventory, the products to your customers, but then you, for whatever reason you can't, then the customers will penalize you. If you're not complying to quality of the products that you promised, then again, you get a penalty for that. Cost because poor handling or transport, and of course, cost of obsolescence. And this is to do with the perishable products. So coming back to the definition of supply chain, so considering the importance of cost and time, here I would like to add to the definition of supply chain. So supply chain is, supply chain's goal is to match supply and demand, but with the lowest total cost and also fastest delivery. Okay, so because then we talk about fast delivery, there are many disturbances to today's supply chain. And I want you to think about what are the notable disturbances to today's supply chain. So when you see these pictures, I'm pretty sure that all of you, but at least those who have seen in the news or who've been in the UK, these were the pictures. Sometimes they still happen too in the UK, but these were the pictures. Happens about 18 months ago in the UK during the pandemic in 2020, when supplies of hand gel, bread, toilet papers are badly affected by the pandemic. And of course, this causing the chaos of the supply chain, some people buying in a large quantity of stuff and causing chaos in our daily life. So pandemic is certainly one of the notable disturbances to supply chain. Secondly, others may remember or may have seen also in the news about the worst winter last year, February. Oh, sorry, hang on, 2021. Yeah, this year, not last year. Texas in February this year. Of course, causing troubles to the Texans. But the bad weather also affected a number of Texas electronic chip manufacturers because of the shortage of electricity. These manufacturers has to shut down the production. But because they shut down the production, then obviously the many companies that use the chips, notably the LED and LCD companies such as Samsung and LG, were also badly affected by the winter in Texas. And the reason I'm showing you the picture here is that you probably realize that Texas is a hot country, and very, very rarely do they have these bad winter. The most recent supply chain disruptions before the last Brexit problems in the UK, of course, is perhaps this blockage of the Suez Canal, causing the bottlenecks and increase the oil price. So the pictures you've seen clearly show the supply chain disruptions in terms of delay and cost. But the next two slides, maybe two pictures that I'm going to show you will give you a sense that actually disruptions are not necessarily affected or mainly affected by external disruptions or external forces, but also can be affected or can be influenced by the change of our internal business process. So for example, this one. I'm sure you probably heard the terms right to repair from newspapers. And this is probably happening already 3 years ago, starting 3 years ago in the US, in Europe, and also in the UK. But particularly in the UK, this summer, UK consumers have right to repair the products they buy, and the kind of products that they have this right to is the washing machine, dishwashers, and so on. So manufacturers or OEM are therefore legally obliged to provide spare parts, at least for the first time, that will then prolong the life of these equipment or appliances and reduces production of brand new products, which is certainly going to be favorable for the environmental protection. But because of the change of this business model, it may pose extra cost to the businesses. And beware, any increase of the cost in the businesses is usually passed on to the customers. So the second thing is this, pictures. Again, my favorite question to you, what is it that these pictures have in common? So a Rolls-Royce aircraft engine, Xerox photocopy machine, Caterpillar, also MAN truck. But for those of you who've had the opportunity to probably read the papers or journals, you probably realize that these companies are all moving on towards the so-called product service systems model. I will talk about product service systems model in a few moments, but in essence, product service systems means that these companies now shifting from selling pure product into selling the integrated of product and services. Yeah. And there are many companies are following the footsteps of Rolls-Royce, Xerox, Caterpillar, and also MAN truck as we speak now. And there are many companies. So let's take a look at how product service systems work. So in essence, the traditional purchase of an excavator or a product would work like this. So the customer will pay, certainly, to buy this asset. Yeah. And because the customer pays the asset, the customer owns the asset, and the customer can do whatever they want with this asset. For example, to dig a hole, to do demolitions, whatever it is. However, because this asset belongs to the customers, then the customers will be responsible to maintain, of course, to monitor the condition of the asset, to make sure that the asset will work 100% available all the time, provide maintenance, provide spare parts, and of course, at the end of life of these excavator or the asset, then the customers will be responsible to dispose of this asset. So that's pretty straightforward. What's interesting here is that there is now the so-called buying excavation capability. So the customers, instead of buying the asset, they are buying the capability of that asset or the functions of that asset. Of course, they still have to pay. Yeah, they still have to pay, but maybe different terms of payment. I'm telling you what the terms of payment in a few moments after these pictures. Here we go. So as a result, then the customers will receive the asset, yeah, as well as the outcome of that asset or the capability that the asset can do. For example, the hole. So when a customer is buying the capability of this asset or this excavation capability, then the customer may receive the excavator as well, or will receiving the hole. Yeah. And the difference, however, is that this customer, because they are buying the excavation capability, the asset itself will remain within the manufacturer or the OEM. And therefore, the OEM will be responsible for monitoring the assets, because buying like this, buying the capability like this, it means that the OEM will promise to deliver either capability, availability, or usage to the customers. And therefore, they have to monitor, provide maintenance, provide spare parts, and even have to dispose of the asset at the end of life. So comparing the two scenarios here, we can see that selling product service systems to the customers certainly will benefit a lot, benefit the customers. But these will be this will cause problems or disturbance to their operations and supply chain. And I was going to show you how it's going to be affected. So this is the logistics and supply chain model that you have seen before. So the manufacturers created or make the product, distributed the product to distributors and the retailers before reaching the customers. But because now OEM is selling the products or the systems, which means that the asset remains or belongs to the manufacturers, at some point, the manufacturers will need to take the assets off the circulation for repair, maybe for refurbishment, for changing the modules, replacing some of the modules, retrofitting, and perhaps remanufacturing before recycling. Yeah. So in this picture, you'll see that the manufacturers will not only deal with the so-called forward logistics to deliver the products to the customers, but they're also responsible in terms of reverse logistics. And the main problems here, as you can see, anything to do with reverse logistics is typically high in profit margin. And as you can see here, anything to take back from the customers to be repaired, refurbished, that would actually incur costs in that. And this reverse logistics part is actually disturbing the operations and supply chain management. However, when you look at these circulation or circles here, you might be thinking, this is actually circularity going on here. And this is the basis of the so-called circular economy. Now let's take a look at circular economy in a bit more detail. But before we do that, let's take a look at the opposite end of circular economy, which is called the linear economy. So linear economy is known for the economy that takes, makes, use, and dispose of the product. So for example, for this can of Coke, they take the raw materials from the Mother Earth, the minerals, and then they make aluminum bars before they turn into can of Coke. But then when we finish with the Coke, we dispose it off. And this economic model is relying on the short product life so that the customer can buy more. And this is probably to do with the availability of cheap, easily accessible materials and energy. And therefore, it's certainly not sustainable. So what is sustainable here? Well, it's a bit more sustainable if when you finish with the product, you collect the product, you could reuse it, perhaps, repair it, remake, recycle before you throw it away to incineration or landfill. And this is what we know as the circular economy model. So the circular economy is an industrial economy, but unlike the linear economy, this model is a model that is restorative and regenerative. So it means that anything must be restored and must be regenerated. However, many people think that circular economy is all about recycling, it's all about reusing and so on. But actually, it has to start, the very beginning of circular economy has to start from the so-called efficiency of resources. It means that we have to minimize the consumption of finite resources, maybe raw materials, energy, water, in the manufacture of the product. It also means that if you can delay or postpone the production of that product or the manufacture of that product, that's even better, because then we minimize the consumption. However, of course, if we need to use or we need to make, or we need to produce the materials or the product, we will make it. However, we need to think about how to prolong the life of that product, how to use that product to the highest utility and value by maximizing the circulation through reuse, repair, remanufacture, and so on. And finally, when the product reaches the end of life, we have to think about how to minimize the content, how to maximize the content that can be reused, and how to minimize others that cannot be used so that it could minimize anything that could end up in landfill or incineration. Talking about circular economy, if you Google in the internet, you will find the Ellen MacArthur Foundation, and they have this diagram. They are one of the proponents of circular economy. They produce lots of papers and books and many educational materials. They are very active in promoting circular economy. And one of the materials that they produce is this diagram. I call them butterfly diagram. It looks like a butterfly. In this diagram, you can see in circular economy, there are at least two types of materials that will be involved in. So the first one is called a technical material or technical nutrients on the blue side, on the right-hand side. And the other one is called biological nutrient or biological materials. And because they are different in attributes, they're different in terms of characteristics, then they will have a different focus too. So for example, the focus of the circular economy for the right-hand side, for the technical materials, is going to be on the maximization of circulation. So the more products circulating, the better. Yeah. And also, the inner circle is better than the outer circle. It means that the effort required to do anything in this inner circle is lower than the outer circle. And therefore, in circular economy, we need to think about, when we finish with the product, how can we do anything that minimize our effort in reusing it? So that's the focus on the right-hand side of this diagram. On the left-hand side of this diagram, however, because the nature of the product, the nature of the materials are not easy to be recycled, then the focus is slightly different. So the focus on the left-hand side would be reducing the waste, reducing pollution, how the materials can be cascaded. Yeah. So when, for example, food or vegetables or fruit, yeah, how fruit and vegetable that are closer to the end of life can be turned into some other products, for example, dried fruit, dried vegetables, so that it can still have value for the customers. So in 2016, we carried out research project to enhance our understanding of circular economy values, particularly. And as a result of that product, we identified three sets of values, and we call them principles, attributes, and enabler. The principles are all the essential activities or guiding principles or guiding rules to be followed in implementing circular economy. So things like cascading orientation, maximizing retained value, leakage minimizations, these are all the guidance for us to do circular economy. However, we also believe that guidance alone are not enough. So we depend on the attributes of the product involved in the circular economy, in circulations. So if the products are not suitable for circular economy, then it would be difficult. So then we define, or we say, the product must have these attributes in order for circular economy to work on them. And also, principles and attributes are not enough if there is no enabler. And enabler includes technology, market, and innovation. So as an example of principles of circular economy, cascading orientation, we aim to keep the materials, be they product, components, longer in circulation, for them to be transformed into different types of products or materials. So that's the first principle, called cascading orientation. There are many other principles, as you can see. An example of attribute is this. The attribute is called circularity. It means that in order for the principles of circular economy to work, the product needs to have a certain attribute, and one of the attributes is circularity. And in this slide, you can see that the product is dental floss, and we argue that in order for this dental floss to be recirculated, it has to be designed for disassembly. So the product themselves has to lend themselves to a circular process, preserving the value so that it can be used longer in circulation. And finally, an example of enabler is this market, the availability of secondary market. And for this reason, I believe that circular economy will flourish not only in the developed countries, but more importantly in the developing countries, because I believe developing countries will have infrastructure for these secondary markets, that we in the developed countries do not have that. So now let's move on to the next part of this lecture, which look into the business models of circular economy. And in the literature, you can see that there are many types of business model of circular economy. But in this lecture, I'm just going to go for 5 of them. So the first one is called dematerialization. It means that we're trying to take out the materials if we do not need it. The second one is called product or service on demand. It means that we do not produce if the customer does not demand the product. The third one is the recovery of secondary materials. The fourth one, repair, refurbish, remanufacture. And the last one is the performance-based or pay-per-use or PSS that you have seen before. Like I said, dematerialization means that we try to reduce, we try to eliminate materials if we do not need, and we change that or we substitute the materials with, for example, digital technology or virtual products. The intended consequences for this is certainly in terms of reduction of products in circulation, and therefore cost of inventory, cost of products, manufacturing time, and certainly bring the impact in terms of environmental. So you see this DVDs change into Netflix. We used to read newspapers on paper. Now we read news on our smart devices. The second business model is called product service on demand. And I said before that if possible, let's postpone. If possible, we don't do anything to stock. We produce or we manufacture only on demand. And it is technologically possible with the technologies such as additive manufacturing or 3D printing. And in the past, you've probably seen that, oh yes, 3D printing is on the rise for plastic products and fancy products like these jewelries. But nowadays it's getting very advanced. And as you can see here, this is a picture, a video of metal 3D printing called Mark Forged. Let's take a look at this video. Oh, I'm so sorry. I don't think I take the voice, but it doesn't matter. You can still see the video. So this Mark Forged metal 3D printing can print metal powder of a wide variety or wide range of materials, from stainless steel to copper. And there are many companies, particularly Formula One teams, they are bringing this 3D printing for their racing to print certain things. The next business model is called recovery of secondary materials, and probably this is the most common or the most often, the most frequently seen business model, especially in the developing countries, whereby we collect, for example, plastic bottles or cans, and then we turn them into a higher value product. And in the next video, you will see that how these secondary materials, for example, plastic bottles, can be turned into something that's a lot more valuable. So in this video, you'll see how clothes are made from used plastics. The plastics obviously chopped, shredded into flakes, and then turned into or converted into pellets. And from these pellets, they produce polyester yarn. the pellets are melted and spun into polyester yarn. That will be the raw materials for the fabric. For example, this fabric used by brands Nike, Patagonia, Quicksilver for outdoor product. And certainly this outdoor product will be very expensive. So you see that how the product, the second life or second-hand products such as plastic bottles can be turned into more useful, more high-value product. Oops, I missed one more. The fourth one is the repair, refurbish, and remanufacture, recondition of product. And this is typical nowadays, like I said to you before, when we talk about manufacture. A long time ago, decades and decades ago, ever since the first jet turbines were invented, remanufactured already exists. And so the main reason is that we need to maintain this jet engine, to overhaul jet engine so that they can be used over and over and over. So the duration or the lifetime is long. Yeah. So jet engine is a typical example of remanufacturing. However, nowadays, many other companies are moving towards selling reman products, particularly companies like Caterpillar, and I know Budebi and colleagues also, Budoki in Trisakti has been working with companies such as Komatsu, looking into remanufacturing area. That's certainly an example of application of circular economy. Oops. The last model, as I mentioned to you before, is the product service systems. How do we deliver product performance or result rather than performance itself? So you might be thinking that, yes, all of this product, the PSS, works because the product itself is high in value, it's expensive, the profit margin is high. Would it work for products with lower profit margin? Well, ideally, it will, providing that we have the mechanisms to do so, providing that we have the right business model and the right operations and supply chain to support that. And for that reason, in this project, in collaboration with TU Delft, Leuven, and also Akun, and some other partners in Europe, Leiden, and also Tecnalia in Spain, we work on this project called Facade Reverse Logistics. The idea is this, that the companies are no longer buying windows of facade, but rather they rent or buy the functionality of the facade. So this is an example of different windows with different functionalities. And the idea is that, as you probably realize, that the aluminum windows are very, very robust, very, very strong, durable, and last very, very long. And therefore, it can be really boring, as you can see in the left-hand side here. It's a really boring window, isn't it? So when you install these windows, you will not take it off until probably 15, 20 years, which means that you cannot be fashionable. You cannot change one to another. But if you are hiring, if you are renting these windows, and if the company that rent out these windows have the right business models, circular economy, where it can be disassembled easily, it can be sent to other places easily, then we can achieve the so-called, fashionable windows, but yet sustainable too. Yeah. So this is what we're trying to do in this particular project, trying to find the reverse logistics mechanisms, how to reuse the windows, and how to rent it out to other people, the business model. However, when we move on to the PSS business model, as I said to you before, the supply chain itself is already complex, yeah, because it's supply network, because of demand amplification, because of the demands of the customers. Now, the company who are moving towards product service systems have to deal with the reverse logistics issue, has to deal with the reverse cycle of the supply chain. And they need to think about where is the location for the dismantling facilities of these windows, for example, yeah? And what are the capacity of these facilities in terms of remanufacturing these windows? So the facility itself if you are learning facility location in your industrial engineering curriculum or subject, then you will imagine this facility location is now to take back the materials or the process or the product from your customers. And these products are all second-hand product or end-of-life product. We talk about inventory. In the traditional production systems, the inventory always comes from the suppliers. But now, as the product you can buy the second-hand product, or the product actually belongs to you as a manufacturer, you need to be careful. You need to be able to reuse your material, your components. So the issues of inventory, the issues where you get the spare parts, should it be brand new spare parts or should it be spare parts that you get from your customers? That is very important. And again, I'm aware that the work of some of the lecturers in Trisakti, again, I think Budoki is also looking into researching on how to incorporate the inventory from the customers, the second-hand inventory. Transport, again, when you look into forward logistics transportation, it's always been distributing from distributor to many customers or retailers. But in this case, it's not distributing, but rather collecting. So what is the network mode for collecting the second-hand products from your customers? Yeah, is it going to be a pool? Is it, what's the mode of transportation? Because don't forget that you will always be dealing with cost and how to reduce the cost for these activities. Pricing, you might be interested in talking to Bu Debbie later on, how Komatsu, for example, deciding the pricing structure for their products. Sourcing, where we get the product from, is it going to be in-house? Is it going to be repaired? Some manufacturers actually repair their own components to be used for their own products. Yeah. How are we going to combine the virgin and used parts and so on? What about the demand, the forecast, the demand forecast? Because we know, or we roughly know, if we have contract with our customers, we probably have a better visibility on how to get that spare part back. And could be the approach is demand management rather than demand forecast. And of course, other things such as obsolescence, when components are no longer produced by the suppliers, and also other risks, for example, risk of the customers not being able to sell back the product to us or to the OEM. I've shown you this picture, but I want you now to look into the left-hand side, because I talk a lot about the right-hand side, about pre-circularity, the business model. And it is true that the majority of the circular economy business model nowadays are focusing on the right-hand side. However, there are companies, there are businesses that also focusing on the left-hand side. For example, this one, coffee or any other agriculture products. So we are working in this project before in order to identify the sustainability risk of coffee production and coffee supply chain. And this part, we are looking into how we can circulate this coffee and also the remains of the coffee processing for other purposes. So how are we going to cascade the usage of this product, coffee? We use system dynamics model to identify parameters that determines the productivity of this coffee. Yeah, and then the output of this we can see in this in terms of the quantity, the amount of coffee being used domestically, exported, and also that can be reused again in the future. The second examples of circular economy that happens on the left-hand side of the butterfly diagram is this. So another project, how to improve the agri-food supply chain and make it more circular by reusing or by processing the waste, food waste into something more useful, as well as to reduce or to prevent waste from happening at the first time. So the idea of agri-food supply chain will follow the so-called cascading use. So the top part here, this is the brand new or the good products, fruit and veg produced at these farms and then distributed through to usually modern retailers. So the product that cannot be sold to modern retailers will probably be sold to traditional market. But of course, nearer the end of life of that product, we will have we will need to think about the cascading mechanisms. Yeah, say for example, to food processing industry, like I said to you before, maybe that fruit and veg can be turned into dried fruit or powdered chili and so on. It may be used by the herbal medicine industry, yeah, maybe donated to community or maybe channeled to other industry as byproducts. And when it is not suitable for human consumption, then it can be sold, it can be used for animal feed, for cosmetics. And if it cannot be used for animal industry, then it may be disposed of, or may be used for energy recovery operators, as well as to be used for compost, for biofertilizers being recirculated to the farms. So here we have the various ways of making our products more circular. The final project that I'm going to show you is this one. So bioplastics. By nature, changing to bioproduct will certainly give a very positive impact to the environment. And in this project, we are looking how social innovation can be used or can address the wicked problems of bioplastics. Now, the wicked problems here is that we know that bioplastic can be made out of different materials, biopolymers. However, we often unclear on how to manage the end of life of these bioplastics. And therefore, we do this social innovation lab to better understand these complex social problems, the whole systems approach on how to manage right from the production of these bioplastics, distribution, used by the consumers, as well as by on reaching the waste processing facilities. This is one of the social innovation labs that we did in the past. Now, hopefully we will do it again sometime in November. Yeah, prototyping the solutions of bioplastics, attended by the stakeholders of bioplastics. So if you're interested in attending it, I will please remind me, would I be to send you the Zoom link? So it's open to anyone. Okay, I have a couple of slides, but I'm going to go for this one first because if you don't mind, I will use the last 10 minutes for me to present a slightly different topic that might interest your students. Okay. So to summarize my lecture today about circular economy business model, so we have looked into how circular economy has changed the supply chain. Yeah, the supply chain that already complex, already difficult. Now with circular business model, it's even more complex and even more difficult. Although it brings a lot of benefits, a lot of advantages in terms of economics, environments, also social. So I'm going to leave you with some viewpoints that I have learned, or we have learned from this Marie Curie projects funded by the European Commission. But the first one is this: circular economy is not just about recycling. So many people thinking when we talk about circular economy, yeah, we did it already. We are doing lots of recycling, and it's not about waste processing. If we talk about with waste processing, it's probably too late, because if we do not control the way waste produced, then it can be too late. But circular economy is more into resource efficiency. We need to control the consumption of our resources, and then we can control so that waste doesn't occur at the first place. We prevent from happening. If the product is already in use, how we can increase its use by maximizing its circulation, by mapping the material streams and supporting processes. And therefore, there are 5 things I want to leave you with. If you want to implement circular economy, you need to have the right business model or circular business model. It has to be starting from the design of the product. We need to decide the selections of raw materials, the selection of the way the product is being produced, the assembly, for example, so that the supply chain and operations issues can be made simpler, and less costly. You need to think about the marketing issues, marketing and sales. You need to think about the customers, because you are dealing with customer image. If you look at a secondary product, they would think that they are buying secondary product, even though that we ensure that the performance of the secondary product is exactly the same as the brand new product. For example, aircraft engines. Finally, you need to have the right systems, tools, and methods to help industry to become more circular. Okay, so with that, I end my first part, which is the actual lecture in circular economy. However, with your permission, Bu Debbie, if I could use the last 10 minutes of my time to present something else.
Okay, please,
Okay.
Prof. Eni.
Right.
Okay.
So I'm going to start with this very topic of Merdeka Belajar, Kampus Merdeka. So as you know that you are now very busy with these activities, 8 activities of study outside campus. It could be internship, could be working with exchange, could be humanitarian. There are many other things. So here in the UK, we have this consortium called UK Indonesia Consortium for Interdisciplinary Sciences, consisting of Coventry University, Warwick University, and also University of Nottingham. And we run this internship program for Indonesian students. Our universities are nearby, not very far away, far apart. And in fact, Coventry and University and the University of Warwick are located in the same city. The idea of this is therefore the internship programs that we offer to the Indonesian students will allow you not only to work with industry, but also doing exchange, because you are, in fact, will be rotated to these 3 universities. The program that we offered, there are 4 agenda items of this program. The first one is called Learning with Industry. Here, the program is about 3 months. You are working with industry, real industry, solving or help them solve their problems and come up with solutions in a group. Also, you will be put into the so-called leadership program, leadership class, that will teach you, of course, leadership subjects and also entrepreneurship. You will have the opportunity to visit a number of companies in addition to the company that you work. And also, you will have the opportunity to sit in lectures in Coventry or in Warwick or in Nottingham. And in the case that you are on rotation, you will also be attending lectures in those 3 universities. In return, you will receive 20 credits, 20 SKS, that then, depending on the host university, this can be accounted for your MBKM credits. So the first batch will run very soon because of the delay due to COVID, but the second batch will start in January or February next year, semester genap. So if you're interested, please contact your international office. I am actually in contact with the international office too, to arrange this program. So the companies we are working for this first batch is Mercedes-Benz Parts Logistics, Malone Group, Omron, Smurfit Kappa, and also Mini Car. So the project's been offered by Mercedes-Benz and Malone. Malone itself has the customers, and their customers are Omron. Sorry, the partners is Omron, and the Malone Group's customers is Smurfit Kappa, which a company producing corrugated carton boxes. Mini is one of the companies who will be visiting for the company visits, as well as JCB Tractor. Okay, so applications and contacts. So please contact your international office at your institutions. The requirements is English language test, score IELTS 6 or equivalent, and a copy of your current passport. So in terms of selection process, you will be selected. We will accept. So the selection process will be done by your university, your international office. The application deadline is around 16th of December 2021, and the enrollment for the next batch would be 17th of January 2022. Okay, so with that, I end my presentation. Thank you very much for your attention. So if you have any inquiries about the projects, the internship projects, please let me know, or please let your international office know, then we can have more detailed presentations, and I can sort of explain the costing, what the schedule, yeah, what you will do and when, in a bit more detail later on. Okay, so thank you very much for your attention, and I'll return to Bu Devi.
Okay, thank you very much, Professor Benny. It's so interesting topics you present to us, and in the end about the internship program, I think it's so interesting. Maybe we will discuss it later. Okay, keep your question, all participants. And Professor Benny, can we deliver the question in Bahasa? Maybe
yes,
the students. Yeah. Okay. Okay. To all participants, you can make a question in Bahasa. Yeah. Okay. Maybe we enter the question. You can take your question in the chat. Yeah. And then we will be back at the question and answer session. Okay, thank you very much, Professor Benny. Yeah.
Thank you, Bu. I see you in the Q&A session. See you again.
Okay, thank you. Okay, for the next speaker, please welcome Professor Dadan Umar Daihani.
Thank you, thank you.
Okay, Prof. Dadan, welcome. Nice to see you.
Yes, nice to see you, Debbie, and Prof. Benny, especially.
Okay. Before Professor Dadan, before Prof. Dadan deliver his presentation, I will read his curriculum vitae first. Okay. Profesor Dr. Insinyur Dadan Umar Daihani, DEA. Yeah, Professor Dadan got his doctor in science from the Aix-Marseille, France. Yeah, please correct me for the pronunciation. Okay, in 1991 till 1994. And then before that, he got the diploma d'études approfondies from the same university, right, Professor? Yeah, in 1990. Yeah. Professor Dadan Umar Daihani is from Institut Teknologi Bandung for the Sarjana Teknik Industri in Okay, in 1974. Oh my God. Okay.
It's too old for you.
So, yeah, I was born in 1974, and then you get your bachelor degree.
Yeah.
Okay, okay. This very much biography you send me about 11 page, yeah. Okay, maybe I need 7 days to read all. Yeah. Okay.
No, it's enough.
Right.
It's enough.
Okay. Right now, Professor Dadang is active in Lemhanas, Republic of Indonesia. Yeah. And he is as assistant director, ya, assistant director 1 bidang akademis program pasca sarjana Universitas Trisakti and director of Tisakti International Business School. And okay, I'm glad you not win the competition. Yeah, Professor Dadang, Professor Dadan has be the candidate of Rector ITB, ya, at 2014, ya, and then in 2020 he is a candidate of Rector Universitas Pertamina, but I'm glad you not win that, yeah. So you still in Trisakti now, yeah. Okay, okay, Professor Dadang, the time is yours. Yeah.
Thank you, Ibu Debbie, as a moderator. Prof. Benny, thank you very much. Your presentation is very excellent presentation. It is very interesting. You present about the circular economy. Nowadays in Indonesia, it's become popular, and hopefully we can learn from you. Thank you very much, Prof. Benny, who always coming to Trisakti University to improve our system. And last but not least, in the last presentation, it is very interesting. I would like to be a student anymore, and I would like to participate with the internship in UK. But,
most welcome, Prof. Most welcome.
Ibu
Please
Debbie,
visit us.
Okay, I would like to be visiting maybe after pandemic. Ibu Debbie, do you know, after Prof. Benny speaking English very well, I am very, you know, I have sometime, or not sometime, I always have difficulties to deliver lectures in English. As you know, I'm graduated from France. I prefer to speak Bahasa or French, as Pak Benny knows. There is a joke. If you would like to mastering the French language, you have to kill first your English language. Because French language and English language is totally different structure. And even sometimes someone coming from UK, if coming to Paris, is totally the different culture. Okay, but anyhow, I will try to present in English, maybe in mixed Bahasa Surabaya, Pak Benny.
Yeah.
Okay. So allow me to share my my slide. Okay, in this great lecturers, I would like to thanks to all of the faculty members of Trisakti University, and also all the faculty members coming from other university. It's most welcome. Hopefully, with the new system of Campus Merdeka, we can more work together, all of university, to create the education system in Indonesia more powerful and more competitive in the world. And as Bu Debbie present, I am choice the candidate of director of another university. I always to be a candidate. I never been with. So hopefully, I work at Trisakti. I love Trisakti University. So the presentation or the title of the today is the challenge or the challenges of production system toward autonomous age. In this presentation, maybe we are not going into detail, but just only enlightening. It's mean I would like to give some idea that in the futures we will go to the system autonomous system. So that's the idea that I would like to present in this presentation. Okay, to make more effective or maybe more organized our system, I would like this presentation will be divided in three parts. Sorry, okay. Firstly, I would like to introduce or describe the dynamic of industrial environment for answering why we have to transform our manufacturing system to be autonomous system. In the second part, I would like also to describe, just only reminding to us the history of production system, since the manual system until now is the autonomous or automatic production system. And in the third part, last but not least, we're focusing about the autonomous production system. As I mentioned before, I not want to go to the detail, but just only describing in general what is the autonomous production system, what is the architecture in general, etc. Dear attendee, before we are going to the this presentation, I would like to mention that this presentation is based on a certain article. Nowadays, a lot of experts, a lot of scientists, a lot of lecturers from a university, from research center, who interested with this system. So we can see every day, maybe every month, hundreds of articles about the autonomous and automatic in manufacturing systems coming, and it is very interesting. This is, I just only pick a certain article, such as David Aborni. The title is Autonomous Manufacturing, Automating the Job Shop. They come from Robotic Institute, Carnegie Mellon University. Another article is very interesting, has entitled Self-Awareness for Autonomous System. This article wrote by Nicky Dut, Carlo, and Regazzoni. Another article also about the conceptual design on integrated autonomous production control model in association with a prescriptive maintenance model. Another article is about the digital twin-based cyber physical production system for autonomous manufacturing in smart shop floor, and also the characteristic of distributed autonomous production control by Hiroki Okubaweng and Hisashi Onari. Another is the journey toward autonomous manufacturing. So I would like to suggest all the students to explore a lot of article about the autonomous, because this system I believe this system will coming soon to answer or to answer the dynamic of industrial environment. Dear attendees, before we are going to I would like to make it more relaxed and not too high tension. Let us contemplate with a lot of the philosopher or expert message. First, I chose the Shakespeare. He said that there is nothing either good or bad, but thinking make it so. So everything will be good or bad if depend on our thinking, our method of thinking. So if we think creatively and critically, I think the result will be good. Another interesting message is coming from Henry Ford. We already know, we learn who is the Henry Ford. Henry Ford is the founder of the Ford Motor Company and is credited with creating the middle class at that time in American society. And I think we believe that Henry Ford is one of the pioneers in industrial engineering. He implemented the mass production system. He was among the first to implement a conveyor belt production system in the mass production, so the car is more affordable. He said that quality means doing it right when no one is looking. So I think this message is also said we have to be creative. We have to see something behind that we can see physically. The third, it is, I think, the reasons, the reasons expert. I fall in love with this message. We have become a white-collar workforce, and automation has become a necessity. Randy Bro is a motion industries president in 2018, so it is in the recent year, that if remember with the tailor, at that time we try to transform from the using of the human power to machine power, and now become all of the critical work, let us the robot to do it. And we come back to the human being to think more creative than work using the muscle. The participants here are things also always do in every lectures, that we have three magic words. That magic world, let's say effectivity, efficiency, and productivity. Every professor in industrial engineering always, this is the magic word that we have to keep in our mind. It is just only reminding the notion of effective, for instance. So it is have a relationship with why we have to develop the system, the production system, more and more autonomous, because we would like to create, to find the method, the effective method. Effectiveness relates to the most appropriate, the way to do a job. Effectiveness is the capability of producing a desired result or the ability to produce desired output. And as Pak Benny also present, it's not only we have to produce the product, but also how we deliver in the fast time, also in the lowest cost. And the notion, the second magic word in industrial engineering is an efficient. It is just only for a reminding also. The efficient, if effectiveness relate to the most appropriate way to do the job, so efficiency is related to the use of resources according to need and avoiding waste in all aspects. Pak Benny also present in the supply chain, in the circular economy, it is not just only recycling, but also have avoiding waste in all aspects, both material, time, and labor. Now we're living not in the linear system, but in the circular system. And the notion of efficient, we can say also how to perform or functioning in the best possible manner with the least waste of time and effort. So the keyword is the possible manners, how to doing something with the least waste. Ladies and gentlemen, I would like to continue to the third magic word of industrial engineering is productivity. The word productive often describes the ability to do a lot of work and earn a lot. I think this three magic word is the best, is the foundation to create the autonomous system of today. Because what is a productive? For instance, we can translate it to do the important task. Now we enter to the very environment, very complex. But I don't want to say complicated, but it is very complex. So we have to do important tasks by good delegation, set priority, and be mindful of the time, energy, and attention, have healthy habit, and also don't forget, we have to enjoy each day. To be a productive person, we have to enjoy our life, and also accept the life happen, smile, be happy, etc. So this is just only reminding us that all of industrial engineer should keep in your mind the three magic words: efficient, effective, efficient, and productive. Dear participants, I would like to continue here to describing that in engineering, something not happen coming suddenly, but step by step. Look at, for instance, maybe Ibu Debbie never using the calculator manual, but in my age, for instance, in 1960, when I was in elementary school, I used to calculate the arithmetic, what we use the calculator manual or the simple, or with another, the stone, a little stone, etc. And then we found the calculator mechanic. I think Ibu Doki, Ibu Didin, Ibu Tina still using at that time calculator mechanic, what we call the slide rule. In 1970 until 1975-76, even in ITB, we don't have any calculator. So the complex arithmetic, to calculate the complex arithmetic, we use the calculator mechanic or the slide rule. In 1976, yes, we can use the calculator electronic, and also the computer, what we call the 1101 computers. It is the big computer, but the memory just only 16 kilobyte, for instance. It is IBM 1101. But before, computer just only created for calculating the arithmetic. But nowadays, computers as another function developed to be a data processing, information processing, computer as knowledge processing, computer as media business, computer as part of social media in IoT today, and computer also become a system, the main system to control the production system. So as we see, and we can see in this slide, the evolution of the manufacturing system. We know, for instance, the first era, the craft production, the Gilda in France, craft guild, manual skill, and workmanship. We use the human workforce rather than machine. But thanks to the James Watt, who created the steam engine, so we move on from manual system to the engine system. We can see in Industrial Revolution, I think all of industrial engineers know this history from steam engine until Toyota making a car, also the belt, the conveyor system, etc. from the Henry Ford. Related or in line with this advancement of information technology and manufacturing system, so we know today the technology revolution, what we call, for instance, it is the slide that very popular of today, the advancement of industrial system. Starting from the mechanization, steam power, weaving loom, until now is cyber physical system, Internet of Things. So the manufacturer using computer not only to control all of the process, but also take the decision if the disturbance coming suddenly. This is, we know by definition, for instance, Industrial Revolution 1.0. Industrial Revolution occurred in 18th century, as we know, as we see in the previous slide. At this time, all the sources of energy are muscle, water, and wind, what we call the human forces. So at this time, making a lot of product means that it requires a lot of human resources and strong. Until finally, James Watt, as we mentioned in the previous slide, invented the steam engine and is considered the forerunner to the development of industrial tool as a machine that start in what we call more productive. As a result, job can be replaced by machine. Today, a lot of people that the born of industrial or information technology, they call a disruption. But in my opinion, it is not a disruption. It is enrich the old method. The transform, replace the old method more productive. Like the James Watt. When James Watt created the machine, everybody happy. Why? Because we can more productive. And we move on to Industrial Revolution 2.0. At this time, this period began in the late 18th, when the automobile industry was produced in large number. That is become what we call the mass production era. And we move on to Industrial Revolution 3.0. This period is the stage where everything has turned to digital. That is very important. It is the starting to develop the production system more automatic. The invention of the computer became the forerunner of the beginning of the revolution industry 3.0. At this time, big countries such as America begin to save their economy from was originally in the industry to an information economy. I think, and at that era, I studied in France. So at that time, it's mean we changed from manual to the automatic, from a fixed system to the flexible system. And today, it is very rapid changes in Industrial Revolution 4.0, as we know, emphasize digitalization so that all things related to production can be more effective. So the three magic words, effective, efficient, and productive, always keep in our mind that then the system, the autonomous system, born or created because we would like to implement that the three magic words. Ladies and gentlemen, now it is only just the questioning, for instance, why we must continuously create more effective, efficient, and productive system. So I always base on or founded my lectures in the three magic words of industrial engineering. The first, we know what is the current issues today? Why we have to create the more and more autonomous production system? Because it is intense competition. We are entered to the era. Globalization, for instance. Yes, market global is give an opportunity for us because we can put our product in the marketplace, globalization marketplace. But don't forget, if market open globally, I think it is not only the opportunity to market our product, but also we have a lot of competitors. And nowadays, our competitors is not just only the competitors in local level, regional level, but also the global level. And at the same time, the product from the UK, the product from Europe, the product from America, from United States and Indonesia compete in the same marketplace. So it is nowadays we have to more creative to create the production system more productive, effective, and efficient. The consequences of intense competition, as I mentioned, that is happen the globalization. Yes, in pandemic, maybe Prof. Benny also agree with me that the global supply chain is a little bit disturbed because of the pandemic. But hopefully after the pandemic, I think the global supply chains will be have the important role in industrial competitiveness. Another issues in this era is product variety and customization. because we can use easily to, or we can produce easily. For instance, as Prof. Benny mentioned, also we can use the 3D not only based on the plastic materials but also in the metal material. So the product should be variety and customization. By using 3D, we can customize. The customer can ask all of the product as they want. So the product variety and customization become the big issues and important issues of today. How we can develop, how we can change our product rapidly? The answer is we have to create the system more flexible and more autonomous. More services, it is another issue. Today, it is not enough just only to produce the product and selling the product, but also we have add a certain services to be a good competitors, to be a good to have the competitiveness level. We have to add our product with a lot of more services. Another issues, of course, it is the classical issues is emphasizing on quality. As Henry Ford said in the previous slide, the quality is always number one. But the definition of quality, maybe it's slightly different. Because the quality standard of today is the most important is conformity to the customer. It is not an absolute quality. So in the quality also we have to learn what is the quality that customer need. Another, this is I think the flexibility. I would like to tell the story a little bit when I was in France, when I studied in the doctorate and the diplôme études approfondies, Madame Debbie, diplôme études approfondies from the Université d'Aix-Marseille-III. It is the pronunciation of Universitas in France. I work at the system to make more flexible. The flexibility become the key. The flexibility is become the keyword that all of the production system at that time try to form to be flexible. I would like to explain after in this slide why we have to be flexible. Another issues in advance in technology, of course, all of the manufacturing now using IoT, using computer as a control system, using the robot, etc. Another issues is environmental and ethical concern. It is, I think, related with the lecturers from Prof. Benny, that nowadays every producers, every manufacturers should respect the environment and ethical concern. If we, for instance, in the next few years, 1 or 2 years later, all of the manufacturers should using the renewable energy. If we produce the product without using the renewable energy, and it will be blocked, we cannot sell that product. So the environmental and ethical concern become the more important issues today. Another, of course, it is very technical. We always we have to find the shorter production development time, because if we produce the product, for instance, as Prof. Benny mentioned also, the delivery time, it is very important, because maybe we can lose the competition because not the development time is very big. And supplier involvement, it is in the supply chain management that since the suppliers until the customers, it is we have to develop the network, the good network and the good collaboration with the strategic alliance. So it is, I think, the panorama of issues that face to our that we have to answer how we can live with this a lot of current issues, and we have to create the production system face to this a lot of dynamic issues, worker involvement, etc. Based on that, threat, we found 4 key concepts. In the futures, we have to keep our manufacturing system based on 4 concepts: more proactive, more adaptive, more flexible, and more synergy. Because the dynamic of economic environments, the intense competition influence all our system. The technology development, IT, we cannot neglect the advancements of information technology. We have to use that IT, that computers, etc., and also market and customer driven, market oriented product diversification influence all of the new character of industrial manufacturing system today and in the futures. Also the quality of course and transfunctional integration. This is the key concept of the synergy in integration. Based on this business of consideration, manufacturer must produce a growing number of customized products which reduce life cycle, short delivery time, and high adherence to order due date. And also we have to respect the environment and ethical concern. So what is the notion of the proactive? I tried to define. The proactive is defined as the capacity, ability, and sensitivity of a business organization to follow, anticipate, and at the same time adapt changes that occur in environment. The word proactive contains the notion of the time dimension. So that is the first character. Whatever you do, whatever we do, we have to create the manufacturing system based on that philosophy, more proactive. The second key concept is more adaptive. What is the definition of more adaptive? I tried to define that this concept is defined as the ability to adapt a business organization to the development of its environment. So the system, the organization, the business model should answer the changes of dynamic industrial environment, economic environment. If in the proactive concept content an understanding of the time dimension, then the adaptability concept emphasizes the spatial dimension. The third character is more flexible. I think it is since 1960, the concept flexibility, it's raised from the research center, the university, etc. The key concept is the flexibility. What is the meaning flexibility? Flexibility can be defined as the capacity to change itself according to the demand of the environment, whether related to the management structure, business pattern, maybe even the product it produced. This is the character that we have to take into account, the more and more flexible. And another characteristic, the new character in industrial system, what we call the synergy, the networking. Yes, we can develop the machine with the principle of decentralized, but every node the system should work together in a harmonious manner. We adopt this definition from Lowers and Locke's, the old concept. Dear participants, I think nowadays I would like to describe for you that based on that circumstances, based on the new character, based on the customer need, nowadays we create what we call autonomous system. So the question, the autonomous system is not an utopia anymore. It is already in reality. We know driverless car, for instance. No, nowadays become popular because driverless car has produced and offered to the customer. Not only, as Bu Debbie mentioned, now I am also working at Lemhanas, National Resilience Institute, and sometimes also I work for the defense industry. Now it is not driverless car. A lot of researchers, a lot of scientists create lethal autonomous weapon. So now we create not a soldiers of human soldier, but we create the robot soldier, autonomous weapon, and the robot who can think as a human being. It is, yes, it's very interesting because by using driverless car, the idea is we can doing everything simultaneously. We can work, we can read, in the middle of the transport. For instance, going to work by using drive car. We put just only the direction, we put just only from the GPS, I would like to go there, and the car take the decision and find, for instance, the route, the very efficient route, the very cheaper route, etc. The ideas from this, or equally by using this idea, nowadays we develop what we call, now this is the challenge for us, the autonomous production system. Firstly, autonomous production control aim to improve production system performance through fast flexible reaction. So the manufacturing, so all of the system capable to react, not only because they work by using the program that we already write, but he can react suddenly with the disturbance or with the issues, what is the problem. So we can say autonomous production control shift the power of decision from a central planning unit towards single intelligent and distributed logistic object, then cope with the rising complexity of today's manufacturing system. Every machine, every robot can take the decision, but they collaborate each other. It is not a dreaming anymore. It is already reality. So this is the challenge for Indonesian industrial engineers to create this system to be compete with other country. For instance, here I give another example. Production improvement start with robotic, what we call the RPR, where you take a repetitive process. At the time, we just only create the robot and we program the robot, and robot will do what we want. But nowadays, robot also can take the decision depend on the situations. The situation happen at that time. So sometimes we confusing the automation and autonomous system. We can, I try to find the definition to make clear, to mix the difference between automation and autonomous system. Automation is a system that has previously been programmed and its function defined by the operator, so that only has a set of function of work that is stable or will not change. This is the important word. Stable or will not change under any condition. So when we program the robot, they will work continuously and repeatedly. So this what we call will not change under any condition. Yeah, okay, unless there are external factors that can damage the machine. And autonomous is different with automation. Autonomous is a system that asks a robot or machine to change its function or work automatically without the help of an operator of human. based on the situation analyzed by the robot itself. So robot can learn the situation. Robot can take decision based on the circumstances that happen at that time. Here, it is very interesting, the architecture. It is maybe to more academic term from Hualong Chen, etc., and his group in the article From Automation System to Autonomous System, an architecture perspective. It is very interesting if we learn, yes, we start with changes from human power to the machine. We already call the automation system, but it's still the automation in the traditional or in the classical system. James Watt invented the speed control, as we mentioned in the previous slide. And nowadays, the manufacturing system, the production system, more clever than before. So he has an intelligence. He has a capability to take the decision. Autonomy is proposed to solve the problem in the process of automation system. Here, the challenge of us, can we create the system who capable to think, to take decision? For instance, if the energy consumed too high, and the system can adjust the system by himself without order from the operator, etc. So here again, in the definition, automation is the automatic control and operation of apparatus process or system by mechanical or electronic devices that take the place of human labor. But an autonomous system refers to the system that can deal with non-program. The non-program is the most important word, non-present situation, and has the ability of particle self-management and self-guidance. That are things in the sense of global, what is the autonomous production system. So nowadays, the landscape or the different architecture of our system. Here we always say the productivity and the flexibility. For instance, we already know the single machine system. Yes, there is very flexible NC machine tools in 1960, 1970. And when I was in France, I already learned about the flexible manufacturing system, but it's still not less productive than another system. So the researchers, the experts, the scientists try to develop another system, what we said the flexible plural machine system. Flexible production line, flexible manufacturing system, flexible manufacturing cell. It is more productive, but again, it's still limited. And we try to develop to more productive the fixed plural machine system in the production line, but it is not flexible. So nowadays, the architecture trend in manufacturing production system, what we call the cognitive factory. The cognitive factory, the factory who can do like the human being. The production system landscape from the perspective of productivity and flexibility, I think it is very interesting if all of the students or all the lecturers in production system learn more about and dig and elaborate more detail in this system. Dear participant, it is I think I will deliver my presentation to the organizers, and all the attendants can have this presentation. Another architecture, say for instance, the degree of control intelligence and the degree of automation. Here, for instance, the operational manually and only manual control by human, we categorize it is in the first level. And then nowadays we have to, we create the manufacturing, flexible transportation, but also dynamic optimization. So what is, again, for the summary, autonomous versus automated? It is just only give an example. Automated process are more like a reflex. For instance, when a doctor taps your patella tendon below your kneecap with a reflex hammer. But autonomous, again, the idea is the system can take the decision. The system can think what happened in this the situation, and they capable to answer the issues, the problem raised at that time. Who need autonomous production and why? Of course, nowadays, the manufacturing, thanks to the technology, thanks to the advancement of the computer system, thanks also to the Internet of Things development, etc., a lot of system, a lot of manufacturing need to transform from the automatic to other autonomous system. That is another challenge that we have to think is workforce side. No one knows what will be happen in the futures, but we have to, for the industrial engineering, more effective, more efficient, and more productive. So we have to be creative, think critically to develop the new system who can answer our need. Here, the advantage of autonomous production system: easy to set up and operate, increase the productivity, consistent in quality, and have a good learning. This is the last philosophy, the very important, have a good learning agility skill. So the system can learn from his experience to improve his result, to improve his process. So what is our challenge? What are the prerequisites for autonomous production? The first is artificial intelligence and machine learning. So the industrial engineers, the mechanical engineers, the computer engineers, the informatician should work together, because nowadays all of this domain should create the system that what we call the artificial intelligence and machine learning, who give the capability and the capacity the system to learn agility of learn. Another prerequisite is machine vision and sensor data processing. It is more operational, and then the simulation, because the robot can think first. When the robot will doing something, they simulate first. Should I go with this option, or should I go with this option, etc. So the robot have capability to choose and to develop an option. Networking and decentralized system, as I mentioned in the previous slide. Yes, robot can do decentralized manner, but he should work together, synchronize and harmonize to make this system work perfectly. And the last, but not least, robot and autonomous transport system is also the key important to circulate our product in the line production. The key factor needed for autonomous production, of course, it is things we have to learn nowadays. Maybe it will change in the curriculum of industrial engineering, etc., because the education in the future should adopt also the advancements of the OSIC, environment, industrial, information technology, etc. So quantity data, we have to organize big data, quality data, sensor machine device, high performance wireless communication, and IT expertise. because we have to develop the system more clever, and every period should add the capacity to learn from the experience. Here, 4 types of intelligence to support an autonomous production system. As I mentioned, basic capabilities is how we create the system can control over its own action, how our system can react automatically, reactivity, and also reactivity is related with the proactivity, acts on its own initiative. So the robot who has an initiative, the machine who has an initiative, and sociality. It is very ridiculous, for instance, we use the sociality for all of the machine, but the most important thing in this notion is interact with other agent. So every robot should work together, interact in the organized manner. The essential type of intelligence for the autonomous production system are self-knowing, action planning, target setting, and scope limiting. That is, all of the students or of the participant can elaborate more in the very interesting article that's written by Hiroki Okuba, Weijingha, and Hisashi Onari, Characteristic of Distributed Autonomous Production System. This is, as I said, the role of artificial intelligence is very important because artificial intelligence drives the realization of autonomous production system. An intelligent production system is a production system that is able to improve itself based on its experience. So they need the intelligence. They need what we call the artificial intelligence. It's mean the intelligence imposed by people to the machine. One of the conditions is to able to learn or have knowledge, the cognitive capability. So the machine should have a capability to learn and the cognition capability of all of the machine that we have. Yeah, this is the notion of cognition. I think we all know cognition is the mental action or process of acquiring knowledge and understanding through experience and descent. So normally people who has this capability, he improve their action based on their experience. But nowadays we create the machine who has a capability like a human being. It is very operational. For instance, how we can measure more productive by using this cognition. For cognitive automation, it means we have to develop all of the capacity from learn from his experience. Here, Bu Debbie, I think I try to make it shorter and we'll give the time to discuss more time to discuss with Prof. Benny because it's very interesting. Maybe 1 or 2 slides I will stop and I turn back the time to the moderator. But I would like to raise, for instance, to present the artificial intelligence, the 7 pattern of artificial intelligence. It is very interesting if we can learn and elaborate artificial intelligence more detail in industrial engineering also. The hyper-personalization, recognition, until the pattern and knowing the pattern of anomaly. So now artificial intelligence is become important in every field, in every domain, not only in information but also in industrial engineering. AI and machine learning, we have to learn. AI is the generic term for algorithm, the enable. Everything now we use algorithm. Everything we use algorithm because we would like to impose our the intelligence to the machine. So the people going back as a human being to use his intelligence rather than the muscle. So the clerical work, even though the intelligence activities, we can give to the robot to replace our job. Machine learning is the key technology of AI, we know already, and using machine learning, it means we expand the application, the capabilities of this system. Another element that we have to learn about the machine vision and sensor data processing, and also the simulation, the capability to create an option. So before we do something, before we take the decision, we try to simulate, go or not go. Which option that it is very valuable, or another option. That is the basic of take the decision. Networking and decentralized system, as we present, it is very important. Yes, we work decentralized method, but every single machine, every single robot should also well organized and work together in the network harmoniously. Robot and autonomous, and this is the last, I think the last slide. It is very important also. It is very interesting when we see the panorama from the digitalization until industrial 4.0. It is first connected, transparent, and last the intelligent. Dear participants, in the last message, I would like to, life has no limitation except the ones you make. So the challenge of us, don't divide our constraint. Please open mind, and we can work openly, and we can work productively, creative thinking, etc. Tetap semangat, keep spirit, and thank you very much. I turn my time to Ibu Debbie. Thank you very much, Bu Debbie.
Okay. Thank you very much, Prof. Dadan. Is it your grandchildren? Yeah,
sorry.
Yeah, I know.
Yeah, it's time. It's our time.
Okay.
Thank you very much.
Okay. It's so insightful presentation, Prof. Dadan. Okay. And now we will enter the question and answer session. All participants can write the question in the chat or raise your hand. And you can use bahasa too. Okay, maybe I will begin. Okay, semua partisipan silahkan bertanya dalam bahasa Indonesia. Silahkan, Prof. Benny sangat lancar berbahasa Indonesia. Ya, jadi jangan khawatir. Ya, kalau Prof. Dadan pakai bahasa Prancis, kita akan keluar meeting, live meeting semua ya, Prof.
Non.
Ok.
Je dois parler français avec vous, hein, parce que.
Yeah, oh. Okay. I have one question from Bapak Sanusi, Mr. Sanusi. Maybe you can probably ask to the Prof. Dadan or Prof. Benny and Prof. Dadan. Please, Mr. Sanusi.
All right, thank you very much for moderator.
Okay. Yes.
Okay, is it clear?
Yes.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Let me introduce myself. I am Sanusi from Batam, University of Ibnu Sina. Okay. Thank you very much for very interesting and lecture from Mr. Benny and Professor Danang Umar. I think this is very good topic and relate to our subject in industrial engineering. My question is, because we know that sustainability is a very hot issue and topic, as we know that to implement sustainability supply chain, especially we want to consider about economic, environment, social aspect. So, because I am very concerned and interesting to do some research in small and medium enterprises, because we know that Indonesia has lots of small and medium enterprises where it also contribute a lot of rubbish, and also sometimes we see around us a lot of rubbish. So my question is, what is the challenge should we consider before we design or apply sustainable supply chain model in small and medium enterprises? This is my first question. And then the second question is, let's say we want to follow and implement the philosophy that cradle to cradle concept. Yeah, cradle to cradle concept. What is the must our government do? Because we know that government as a regulator maker, yeah. So everything we have to follow. Also, our concept is good, but if the government is not agree with our system or our model, it also got nothing. Yeah. So I think that you also know that supply chain is very complex. You know, especially in Indonesia, there are many uncertainty things. For example, about the regulation, about the society, and also there are many aspects we have to consider. I think that's all my question. Thank you very much to moderator and to the professor. I think it's very, very good time for me to attend this seminar. I say thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Sanusi. So maybe Professor Benny and Professor Dadan can directly answer the question. Yeah. Okay. First, please, Prof. Benny, to answer the question.
Okay, thank you, Bu. Prof, izin saya menjawab.
Yeah.
Okay, so yes, as we all know, the main issues anywhere, not just for SMEs, is cost. And especially for SMEs, costs become more critical, more important, especially when we look into sustainability. We think, well, we put it this way. To be honest, sustainability can be seen as a costly activity. It's not something that it's not yet been seen as something at the core. It's not a revenue center. It's mostly seen as a cost center. Until we are faced with other things. For example, I actually will speak to the Swiss Chamber tomorrow, and with the very topic, and the companies are asking me, yes, how do we deal with this sustainability? But the companies I'm talking together tomorrow, Hilti, they clearly say the two things that's really, really important for them. Number one is that they said, Pak Benny, our customers now changing. They are changing the attribute, the characteristics of their customers are now changing. They want us to be sustainable. That's number one. Number two, Pak Benny, if you don't do it now, we will be hit by regulations. We will be hit by other policies. If we don't get ready now, we will be hit by that very hard. And it's going to be even more costly in the future. So how do they turn this cost into opportunities? Number one, they said, since a long time ago, we always work with lean manufacturing, waste prevention. But often we only look at the waste from the point of view of waste from the factories, waste from our non-value adding activities. But if we see that environmental issues, waste that is jeopardizing our environment, be seen in the same way as we see waste in manufacturing or production, then in the future we will get used to it. Kita akan biasa dengan hal-hal semacam itu kalau kita berpikir bahwa environmental concern is actually part of our waste reduction project in our company. And from that way, if we are looking into waste prevention, then it will cut our cost on waste processing, Because when we are creating waste, it will be too late. It's like when we work anywhere in the kitchen, in our house, we make up waste. But if we work carefully so that we don't create waste every time we do things, then we don't have to spend effort in tidying up. That's just the similar analogy. Pak. So if we work, berantakan, then we have we need a lot more time and effort to tidy up. So that was the answer. I don't have the answer for that. I have the answer from the company, from Hilti, that they told me how important it is for them now to think about sustainability. Of course, like I said to you before, Hilti is a large company, it's a Swiss company. But I think we can all learn from this. And hopefully for the small and medium companies, it's even more important, is even more critical to be waste aware and, promoting waste prevention rather than waste processing. Sorry, and the second question, from me, it's government will need to do something about it, and it's obvious. If you read news yesterday, actually, Boris Johnson, Prime Minister of the UK, he said, well, of course, just before COP26, it's political reason too. COP26 will start in about 12 days, in 2 weeks' time, and he said they will reduce the carbon by giving incentive to houses to change from gas boiler. We don't have air conditioning here. We have gas boiler. They will change gas boiler to something else, gas heat exchanger, basically. Yeah, take the heat out of the air and then turn it into heat for house. So this equipment is not cheap, and therefore the government will give incentive, £5,000 help to every household to change. But he's still being criticized. It's not enough because there are so many households here, and it's not enough. But the government is giving that money to. Well, of course, again, you could argue that UK is a wealthy country, can do things. But what I'm trying to say is that even at the level of the UK, there's still the roles of government still being very, very clear in helping out industry and helping out households to become sustainable.
Okay. Okay, is it clear, Mr. Sanusi?
Right.
And maybe Prof Dadan, you can give another statement about this question.
Okay, Bu Debbie, I think the answer from Prof. Benny is very clear and it's clear of the problem. But I would like to maybe a little bit philosophies in the sustainability. The sustainability means think for today, but without damaging the futures. In bahasa, I would like to say, kita berpikir dan bekerja hari ini, tapi jangan lupa, jangan merusak masa depan. That is the philosophy of the sustainability. It means if we consider, what is the meaning waste? Because we are today we are not using something. Oh, it is not. I need, so I throw it. But if we think everything is valuable, so there is no waste term anymore. So the most important thing is things do today, but don't destructing the future. The second question, yes, I think the governments and all of the stakeholders should work together. But Pak Sunusi, in my opinion, in my research, the SMEs have in bahasa memiliki kemewahan to change because that is very small, so very flexible. In this the crisis of economy, maybe Prof. Benny can also give an insight. Who the big company hit by the crisis economy, and the small flexible, the small can change and it means face all of the circumstances. So for me, as MA, the most important thing is can more survive than the big company today. That is the advantage of the small. But of course, as Prof. Benny said also, governance should also give a compensation, give a facility to the SMS to make SMS more survive. That's Bu Debbie, maybe Pak Sanusi is answer your question.
Yeah. Is it clear, Pak Sanusi?
Thank you very much, Prof. Benny and Prof. Dadan. I think it's very clear and can change my mind. At least I will try to change from myself. Yeah. Okay.
Yeah, okay.
Thinking for the future. I think that's all. Thank you very much to moderator. Assalamualaikum warahmatullahi wabarakatuh.
Yeah. Waalaikumsalam warahmatullahi wabarakatuh. You're welcome. This is so interesting. Yeah, like Professor Benny said that supply chain is very, very costly. Yeah, but we know that business as usual, yeah, Prof. Benny, is hard to change. Yeah, and like Professor Dadan said, yeah, jika kita bisa menggunakan sekarang, jangan sampai di kemudian hari keturunan kita nggak bisa pakai gitu ya, Prof, ya, di Indonesia di bahasa. Yeah, okay, it's so interesting. Yeah, participants, any question? Yeah, okay. Okay, I have a question. Yeah, if anyone can. Okay, I have a question for Prof. Benny. Yeah, Prof. Benny. Talk about the change. Yeah, change from buying product and now buying capability. Yeah, you said, yeah. And then how can we safely involve to this system as industrial engineering, and what should we do? Yeah, and you know, we right now for the student we learn about manufacturing and then about service, yeah, and then we change the about buying product and then buying capability. Yeah, how can we get involved to these changes here for the industrial student? Yeah.
Okay, I'll try to answer. Yes, it is. It is not easy. Like I said to you before, the product service systems model, it's great for the customers because the customers nowadays are buying capability in the sense that they are renting. They are paying as they use, or they pay per month. So when they pay per month, they can use the equipment as and when they need it. When they pay per use, that means they have no risk in terms of maintaining it. They only deal with the variable cost. Every time they use, they pay a certain amount of money. If they don't use, then they don't pay. However, this on the OEM side of it is really complicated, isn't it? As you imagine, companies like Komatsu, well, you might be able to tell me the answers. You work with Komatsu, and they are they need to be really careful. They really need to be careful because now they are mixing the two things. They're mixing the two channels, the channels of brand new products and also the channels of the second-hand product. Although when we say second-hand product, it doesn't really matter. If we sell the capability, it doesn't really matter whether we provide second-hand products or brand new product. It doesn't really matter. What matters for the customers is that they can use the product, they can use the function as and when they need. And therefore, there are a lot more that industrial engineers need to get involved in that. For example, on how to do the optimization, to do planning, to do inventory management. The inventory management systems nowadays with the product service system is going to be more complicated because there has to be two streams of input. The one input from existing suppliers and the other one is from customers. So our customers are now our suppliers. And also what's interesting here is that the mathematical model is going to be a lot more complicated unless we are able to create a system whereby we can make the channels transparent, so we can use information technology to trace where the part is. And the problem with our current system is that we always work with forecasting systems, then we are trying to make our forecasting model more and more accurate. It's like we having a tool, and we make our tools. It's like we have a gun. So say we have a gun, we design a gun so that this gun can shoot really well. But perhaps if we can control our target, we make our target more easily to shoot, rather than creating the best gun. If you see what I mean. So that could be a role of industrial engineers to so we say we look at the demand, and if it's possible, we manage the demand in such a way that we make it more transparent, so that we don't have to create sophisticated forecasting models, let's say. And for this, the reason why I'm saying this, because with the advance of technology, the advancement of Industry 4, now it is possible to exchange data. If we slightly move to our friends in civil engineering, they are working with BIM, Building Information Modeling. BIM is very, very interesting because everything is in computer models. The data, the requirements, it's very similar. The bill of materials of the building is in BIM. What's interesting is that if we can link this BIM with the inventory model, with the supply chain model, and if we can insert the requirements for reverse logistics, for example, this building, when this building is demolished in 20 years' time, we know that this materials can be recycled, this material can be reused, for example. At the moment, that information doesn't exist. It means that when we move on to circular economy for the civil engineering and constructions, it would be more difficult for them it would be probably be too late for them. Yeah. So coming back to the industrial engineering area, if we are able to build computer systems similar to BIM that can provide visibility to the whole supply chains, including the production, then hopefully we can achieve these circularity in a cheaper way, in a more cost-effective way.
Yes, okay. Thank you, very insightful, Prof. Benny. Okay, the next question from Pak Dadang Surjasa. Please, Pak Dadang, you can, Pak Dadang, you can speak. Or I just read your question. Okay, Prof. Benny and Prof. Dadan. Right now in Tesla producing e-car, Elon Musk totally have different approach in manufacturing paradigm compared to Toyota, for example. Toyota have TKM approach that have to be prepared as PDCA approach with continuous improvement strategy. But Tesla produce its e-car with startup approach in this producing, like produce laptop and other gadgets. What do you both think of Tesla in connected with manufacturing strategy? Okay, for the first, please, Prof. Dadan.
Okay. Thank you, Ibu Debbie. Thank you very much, Pak Dadang. I think maybe I'm success to promote the autonomous. No, because Elon Musk, Tesla, etc., try to develop. It means because now the situation is changed. The something stable is changed itself. So we have to adapt with the change. I'm very interested with the discussion where Prof. Benny said before that we need more and more system capable to analyze, to calculate data, etc. So Pak Dadang, the Toyota and Tesla, it's a different philosophy, but Toyota ways based on what you call the TKM and also the continuous improvement, I think the principle itself is not different. Something different is the translation, not the strategy, the base strategy. Yeah, I think Tesla or the Elon Musk, etc., always using the continuous improvement with the different way. So I think we cannot face to face between Toyota and Tesla. But the principle of the continuous improvement, yes, it is the principle of industrial engineering. As I mentioned, that the three magic word of industrial engineers, wherever you do and whatever you do, it is efficient, effective, and productive. And Toyota translate the efficiency, productivity, and by using more continuous improvement. Tesla also the same. How to make it more productive? How to make it? But nowadays we have a possibility to using the artificial intelligence, using what we call the creating artificial environment to make our manufacturing more smarter than before. So for me, it's not a different thing between the philosophy, but the translation, the implementation of that philosophy, of course, it's different between the Toyota with the maybe I call it is the old system, the old fashion, and Tesla with using the new spirit, like the unmet lethal system, and also drone, and another is vehicle with the driver. Maybe that's my answer, Good Ebi.
Okay, thank you, Prof. Dadan. And Prof. Benny, please your answer.
This is my opinion. Will not be the right answer for that, but this is my opinion. Yeah.
Yes.
If we look at the two vehicles, one is certainly much more complicated than the others. So the internal combustion engines, for example, the bill of materials is huge in comparison to electric car. Electric cars, body, powertrain, and if we look at powertrain, batteries and motors, and the electronics inverters, so to change the current. And I guess that because of that, then it is possible to start or to begin the production process from the startups because of the simplicity of that. Again, this is my opinion. I'm not the expert in electric cars or even the ICU. But when I look at, when I linked it with my talk this morning, that it started off with the attributes. If we want to do the, and that's the reason why a circular economy would work much more easily in the case of electric cars or EVs, because the way it's built is it's a lot simpler. It's only motor and batteries. Well, of course, when we talk about batteries, it is very complicated. The motor itself is also, and also the electronic systems, especially when you make the cars autonomous and so on. But in principles, when we want to do that circularity and also supply chain, it's inherently, because of the attribute of the cars, of the electric cars or electric vehicles, is a lot simpler than the ICE. And therefore, the time taken for Toyota to move on to be efficient and productive is a lot longer. Because inherently the product itself is very complicated to put together, to make economically viable through mass production is it's taking a lot longer in the case of internal combustion engine cars than electric cars.
Yes. Okay, thank you very much, Prof. Benny. Pak Dadang, is it clear? Okay, thank you, Prof. Benny and Prof. Dadang. Thank you for the clearly answer. Okay, all participants, there's time, still about 5 minutes. Any question? Please no worries to use bahasa, oke? Okay? Oke, sepertinya pada diam semua karena takut pakai bahasa Inggris, Pak. Silakan, Pak. Prof Benny from Surabaya ya.
Silakan, Bu.
Oke. If that no answer, okay, I will try to make a conclusion from what the speaker said today from Prof Benny and Prof Dadang is two very insightful presentation. Yeah. From Prof Benny said that about circular economy that change the supply chains from the complexity things and make it more simple with circular economy. And there's two what that I can underline about the resource efficiency and waste prevention. Yeah, and there are some business need to consider. Yeah, how about the material? How about the material? How about the market? And especially the process. It is very interesting from presentation from Prof Benny. Yeah, and then from Prof Dadan. Yeah, I also underline 3 magic words. Yeah, every student from industrial engineering always hear about the 3 magic words: effective, efficient, and productive. Yeah, and then Prof Dadan also present about that nowadays job can be replaced by machine. Yeah, and he said about the automation and autonomous. Yeah, the differences about automation and autonomous. That automation need operator, but the autonomous no need operator. Robot can do it itself. Yeah. Okay. Beware. Yeah. Industrial engineering. in the industrial engineering, you can replace by the robot. Yeah. Yeah. But there are 4 key concepts for the future. We must more proactive, more adaptive, more flexible, and more synergy. Okay, that's all that I can conclude for shortly. Yeah, this. Thank you very much for Prof Benny Cahyono and Prof Dadan Umar Daihani. And all participants, please give applause to great professor. Okay, thank you very much. Okay, before we end the session, Ibu Rina Fitriana will give the certificate award for Professor Benny Cahyono. Okay, please. Okay, Prof Benny.
Very much, Prof Benny.
Thank you, Bu. Terima kasih sudah mengundang. My honor
Prof
and
Benny-nya
pleasure.
dipin.
Oh, okay.
Please pin the Prof Benny. Okay.
Okay, thank you, Bu. Terima kasih.
Oke, terima kasih Prof Benny.
Berkunjung lagi ke Trisakti.
Walaupun dari jauh ya, Prof. Selamat siang berarti di sana ya, Prof ya, sudah siang.
Di sana ya, sini masih siang.
Oke. Next for Profesor Dadan Umar Daihani, please Ibu Rina.
Mas Prof Dadan.
Ya.
Dari bukunya.
Terima kasih.
Ya, terima kasih. Before we end this Studium Generale, and we will take the photo, and please Ibu Fani, you can coordinate the photo session.
Okay, thank you for Mrs. Bu Debbie. So we are entering a group photo session. For all the participants, please open your camera, and I will start from the slide 1. Please open your camera and smile. 1. Okay, ready? 1, 2, 3. And second slide. Okay. Third slide. Please open camera. The fourth slide. The fifth slide. And the last. Okay, thank you for your cooperation.
Okay, thank you, Ibu Fani. Okay, this is the end of this session. Once more, I would like to thank to the speakers for the informative and interesting in presentation, and especially for all the participants too. Yeah, you are very active participant. And finally, behalf of Industrial Engineering Department, I would say to sorry if this session any yeah, okay. And finally, I said thank you for Prof. Benny and Prof. Dadan and all participants. Alhamdulillahirabbil alamin, we can end this session. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih semuanya. Terima kasih, Prof.
Terima kasih. Okay, see you next, Benny, Prof. Dadan.
Sampai jumpa lagi.
Ya, terima kasih.
Prof. Dadang.
Oke, sampai ketemu.
Pamit.
Izin live ya.
Izin live.